Dear YouTube manual reviewer, the limited danger and violence depicted in this video is for educational purposes only. And also in this case, it pertains only to zombies. So could The Last of Us happen in real life? And turn our next door neighbors into bloodthirsty cordyceps infected mutants?
What are we doing, Joe?
I sure as hell hope not. But with HBO's live action adaptation infecting our homes, many of us have imagined ourselves in Joel's shoes. And since the infection behind the Last of Us pandemic is grounded in a real process by which the parasitic fungus ophiocordyceps unilateralis hijacks the body of tropical carpenter ants, the show has an elevated level of realism. This flashback from the first episode alludes to these so-called zombie insects.
There's a fungus that infects insects, gets inside an ant, for example, telling it where to go, what to do, like a puppeteer with a marionette.
And a gruesome, but at the time hypothetical end result, if that virus were to infect humans.
Billions of puppets with poisoned minds, one unifying goal: spread the infection to every last human alive.
It also provides us with an explanation as to how this fungal infection could evolve to spread to humans.
Fungi cannot survive if its host's internal temperature is over 94 degrees. What if the world were to get slightly warmer?
Yes, in the series, global warming is responsible for the deadly mutation of the Cordyceps fungus. Fortunately, in our world, although global warming could conceivably exert evolutionary pressure on a specific strain of fungus to adapt to tolerate warmer environments, the time frame in which this process would occur is much longer than depicted in the show. And as we will see, temperature is not the only factor that limits cordyceps' parasitic ability. It took a long time for ophiocordyceps unilateralis to develop all the tools necessary to zombify their target species of ant. João Araujo, a mycology researcher and cordyceps expert at the New York Botanical Garden, says as much in an interview conducted by Eric Voss of New Rockstars here on YouTube.
Cordyceps have been evolving with their insect host for over 100 million years ago.
This video is an excellent resource to quell any worry over zombie infection. Thankfully, evolution, Mother Nature's painstaking process of trial and error, is our most effective defense from the Last of Us infected, at least in our world. Global warming cannot account for millions of years of evolutionary innovation.
They have been developing this ability to infect the insect, overcome the immune system, seal the insects with fungal hyphae, but preserving the insect brain.
There's a lot to unpack here, and we'll talk details momentarily. But for now, suffice it to say that the evolutionary jump between one specific species of carpenter ant and a mammal, let alone a human, is too far to travel in one fell swoop, as there are many gradations that must exist in between.
So in order to jump from infecting an ant and becoming a mammal, a human parasite, it would require so many genetic changes.
And hence, what we are dealing with here is a work of science fiction. Thanks for setting the record straight, João. Luckily, as many of you already know, applying my medical knowledge to hypothetical science fiction conundrums is one of my favorite things to do. And though we don't have to worry about cordyceps infected IRL, a close examination of the mechanisms that make them click can teach us a whole lot about human anatomy. As for the infected in The Last of Us, the more you learn, the scarier they become. In order to understand why, we'll need to deepen our understanding of parasites, since that's what the cordyceps fungus truly is. The CDC defines a parasite as an organism that lives on or in a host and gets its food from or at the expense of its host. A parasite that lives within the body, like a flatworm or say a fungus, is known as an endoparasite. Conversely, ectoparasites are organisms that live on the skin of the host, like a tick. If I had to choose, neither. One important feature to note is that a parasite has no use for a dead host. At least not right away, that is. And an organism that is already dead cannot be infected in the first place. Some human parasites, says Bobby Pritt, director of the Mayo Clinic's Clinical Parasitology Laboratory, don't cause symptoms or they cause very minimal symptoms. So they're not likely to come to medical attention until it's too late. But don't panic, because many of these parasites can be treated effectively, and some do not even require treatment. Take toxoplasmosis, a parasite transmitted by cats, and estimated to affect 18% of Americans, which can be kept in check by a healthy immune system. The risk is more pronounced for those living in developing countries with warmer weather, with lower access to healthcare, and less sanitary food production guidelines. A recent study in Biomed Research International tells us that globally, due to intestinal parasitic infections, around 3.5 billion people are affected annually by intestinal parasitic infections, and more than 200,000 deaths are reported annually. Hence, the importance of the push for access to basic health care, clean food, and water around the world. Because even in fiction, this rings true.
Best guess, cordyceps mutated. Some of it got into the food supply, probably a basic ingredient like flour or sugar.
In our world, the parasites transmitted in this manner are less deadly than cordyceps.
There were certain brands of food that were sold everywhere, all across the country, across the world. Bread, cereal. You eat enough of it, it'll get you infected.
But this type of thing is still a legitimate concern, especially in the areas we talked about before. And even more so when you think about how often people travel in this day and age.
Kami butuh bantuan Bu Ratna untuk meneliti spesimen yang telah kami persiapkan.
Ini ophiocordyceps.
The show's writer's decision to place the origin of the virus in Jakarta, Indonesia, makes sense. Although fairly industrialized in 2003 when the virus hit, the city is densely populated, surrounded by less modernized areas, and the temperature rarely drops below 20 degrees Celsius. The game chose an equally viable origin story in South American crops. In nature, parasites can be devastating, keeping their host alive, though sometimes in a mentally altered, physically disabled, or entirely catatonic state, until their goal has been actualized. Take the emerald cockroach wasp.
That attacks cockroaches with venom that blocks a neurotransmitter that allows the cockroach to control its own movements.
That's Stephanie from the YouTube channel Real Science. We'll hear more from her in a moment. The cockroach is unable to move, but its brain still functions. Scary. And what all of this means for The Last of Us is that the infected host's body are still alive. The parasitic fungus hijacking their functions to infect as many people as possible. To some degree, the person may still be conscious, trapped inside as their body tries to eat our brains. Perhaps the infected can be heard crying in The Last of Us because they are in fact still aware and completely unable to do anything about it. They are the hopeless cockroach, being led by the arm of the wasp. Wait, fungus. In episode 1, the doctor in the flashback warned of mind control and alluded to hallucinogenic properties of the fungus at the root of this interaction.
Gets inside an ant, for example, travels through its circulatory system to the ant's brain and then floods it with hallucinogens.
I get it. Hallucinogenic mushrooms are all the rage. But the reality may be more gruesome. Let's listen in on the video entitled, "Could the Cordyceps fungus really take over?" from the YouTube channel Real Science, which we mentioned earlier.
Scientists wanted to know what part of the ant's body the fungus infects.
All right, interns, place your bets now.
They found fungal cells not just in the ant's head, but also in the thorax and gaster, and in abundance inside the legs.
This is fascinating stuff. So I tracked down the 2017 study that Stephanie was referencing here. The researchers used electron microscopy and 3D reconstructions of host and parasitic tissues to reveal that this fungus invades muscle fibers throughout the ant's body, but leaves the brain intact, and that the fungal cells connect to form extensive networks. The connections are linked to structures that aid in transporting nutrients and organelles in several plant-associated fungi. Let's have a look. Here we see that the fungal cells, red, surround but do not enter the brain tissue, green. Thus, the researchers were able to deduce behavior control does not require the parasite to physically invade the host brain and that the parasite cells may coordinate to change host behavior. Doesn't science get you excited?
Isn't like scientific glassware lovely?
The full arrows, not the arrowheads, denote fungal hyphal bodies, in red, identified by their short rod-like structure and the presence of septa. The hyphae that they're referring to are branching thread-like structures that divide into cells by internal walls called septa, singular septum. This entire root-like structure is referred to as mycelium and should be very familiar to Last of Us fans. But interns, don't let that hot, steamy kiss of death distract you from the article about the ants, where the researchers
looked closer at the fungus growing in the rest of the ant's body. They found fungal cells present between the muscle fibers in both the head and leg regions.
3D modeling allowed them to determine the ant tissue to fungal tissue ratio and showed a fungal abundance in muscle tissue. In image A, we see a single fiber of an ant mandible adductor muscle, in red, surrounded by 25 connected hyphal bodies, in yellow. Connections between cells are visible as short tubes, and many cells have hyphae growing from their ends. It's no surprise that healthy muscle is normally a tightly packed system of fibers with no spacing in between them. But unfortunately, the ant's immune system is insufficient to prevent this spread. A 2020 article published in Virulence tells us insects possess an immune system that shows many similarities to the innate immune system of invertebrates, but they do not possess an equivalent system to the antibody-mediated adaptive immune response of vertebrates. But if for some reason we were immunocompromised and the fungus could bypass the adaptive immune response to spread between our individual muscle fibers, well, horrifically, and I'm totally joking because this is an incredible article, but bear with me for dramatic effect. While researching for this video, I came across an article entitled Advanced Mycelium Materials as Potential Self-Growing Biomedical Scaffolds, published last year in Nature. It turns out, so states the article, mycelia, the vegetative part of fungi, are emerging as the avant-garde generation of natural, sustainable, and biodegradable materials for a wide range of applications, such as a bioscaffold material for tissue implants. Yo, bro. My implant is made of fungus, yo. I'll just leave this image here. Look at the similarities between the structure of the fungal mycelium and the human extracellular matrix. Images B and D show two types of mycelia after initial growth, and images C and E show the composition after further treatment. I'm an orthopedic surgeon.
You don't say.
And I see bones every day.
You don't say.
And that mushroom, my friend, looks like a bone.
He didn't say.
And now, allow me to direct your attention to the article's conclusion. We demonstrated for the first time that mycelium from Pleurotus ostreatus can be directly used as a scaffold for the growth of cells, determining attachment of primary human fibroblasts with excellent viability and morphology comparable with that observed in the control samples. Anyone know what Pleurotus ostreatus is?
Pleurotus ostreatus.
The freaking oyster mushroom.
These are really beautiful specimens of it.
Hold on. I need to breathe. If we use modern technology to bioengineer a strain of this oyster mushroom that is compatible with human tissue, immune system and 100 million years of evolution be damned. What? Hold on. Okay, I'm good now. This is especially concerning because of the way in which fungus communicates.
So you ever hear the one about the two mushrooms that were hanging out in the forest?
Yes, in a sense, mushrooms can talk to each other.
One mushroom said to the other, "Man, it's hot out here today." And the other mushroom said, "Holy shit, a talking mushroom."
Now, you won't hear tiny mushrooms talking away to each other at night in shady forests. That would truly be the stuff of nightmares. But through the magic of electrical impulses, it seems they are talking all the same. I found that last line in an Everything GP article and had to use it because it's a fun image. But the real fun starts with the research of Andrew Adamski of UWE Bristol, which the article references at length. Adam and his team placed electrodes along the roots of various species of mushrooms and found that their electrical impulses were not random, but ordered in a sophisticated fashion. They found fungi conduct these electrical impulses through long, underground filaments called hyphae, which is similar to how our nerve cells transmit information inside our own bodies. In a side-by-side comparison, the long branching strands of hyphae even look similar to the branching nerves in our nervous system. Do you see where I'm going with this? Now, before we move on, we learned from the article about the ants that mycelium can spread between individual muscle fibers, and it knows to leave the central nervous system intact. And it communicates in electrical impulses. I mean, instead of consuming or replacing human tissue, as I have seen in some of the Last of Us lore, the fungus will want to work in concert with it if possible, hijacking our central nervous system as if to pilot a human meat shoot. Here's how it might go about doing that. The phenomenon of human movement is enormously complex, but let me give you a quick overview. Our nervous system has a central component comprising the brain and spinal cord, and a peripheral component, the nerves that branch off of the spinal cord and extend into all parts of the body. With this system, motor neurons allow for both voluntary and involuntary movements through innervation of effector muscles and glands. Upper motor neurons originate in the cerebral cortex and travel down the brainstem or spinal cord, while the lower motor neurons begin in the spinal cord and go on to innervate muscles and glands throughout the body. However, as Dr. James Neerim, professor of neuroscience at Johns Hopkins University, reminds us, even though the motor system is composed of many different types of neurons scattered throughout the central nervous system, the motor neuron is the only way in which the motor system can communicate with the muscles. Thus, all movements ultimately depend on the activity of lower motor neurons. So let's suspend our disbelief a little further. If the fungus concentrated in and around muscle tissue and in some way inhibited the signal that is transmitted at the neuromuscular junction, it could impair movement. To produce this all-important movement signal, motor neurons release the neurotransmitter acetylcholine at a synapse called the neuromuscular junction. What if the fungus could also produce this chemical? Well, according to a 2015 publication in Eukaryotic Cell, acetylcholine synthesis has also been demonstrated in bacteria and fungi. Of the fungi tested, oriental yeast, matsutake, and shiitake mushrooms, only the stems of the shiitake mushrooms contain substantial amounts of this acetylcholine. It's a stretch, but some fungi do contain the molecule that our nervous system uses to trigger muscle movement. A process that hijacks muscular function in this way would not require any form of hallucinogens to succeed either. If the majority of the central nervous system is left untouched in an attempt to keep the host as close to normal function as possible, the host could be conscious as the infection progresses. However, singular muscle contractions do not equate to smooth human movement. Let's check back on our ants and a clip from Into the Shadows here on YouTube.
Controlling the movement of a whole body is tricky for a brainless fungus, and the infected ant will stagger around the canopy like a drunk.
And although the ant eventually finds its way to its final resting place,
a north-facing leaf, 25 centimeters from the ground, temperature of between 20 and 30 degrees Celsius, humidity between 94 and 95%.
This is a far cry from the speed and agility demonstrated by the infected in the series, and a human's musculoskeletal system is far more complex. We do know that upon being bitten, the Last of Us infection takes 2 days to spread throughout the new host's body, gradually turning them into a runner. Given the size differential between the human and an ant, a process sufficiently intricate to hijack our nervous system in the way that we've laid out would likely require more time. Even in ants, it takes longer than 2 days.
Over the course of the next week, infected ants appear perfectly normal and go about their business undetected by the rest of the colony.
For our purposes, let's say it takes the infected a couple of weeks to turn completely. What if, during this time, the fungus is listening to the nerve impulses, encoding and storing information as if to build a human movement's command list? I mean, even our most powerful technology has difficulty reverse engineering human movements in that way. So, good luck, fungi.
I'm a fun guy.
For more on that, check out my video on the Neuralink implant and its upcoming human clinical trials. Now, what if the fungi had some way to collect and store information over longer periods of time, learning and refining as it goes? From what I understand, an extended infection life cycle, up to 20 to 25 years for bloaters, is already in place in the series. According to this line of reasoning, it may make more sense for the stages of infection to become more physically mobile as the infection spends longer in the human body. But of course, that is not the case, as the fungus impedes physical movement more and more as it progresses, increasing the strength and defense of the victim along with it. Several years into the infection, bloaters are slower still. After 20 years in the shadows, the Rat King is a complete tank, but not the most mobile enemy you'll face. Actual movement coordination aside, there is plenty of evidence that supports the fungi's ability to alter our physiology in meaningful ways.
I love cordyceps for workouts, for pre-workout. It's like it gives you an extra gear. It's really kind of crazy how effective it is.
It sounds like Joe has had some positive experience with cordyceps supplementation. And when a host first turns into a runner, they definitely seem to have an extra gear. Remember Granny?
What are we doing, Joe?
And Rogan's guest, an American mycologist named Paul Stamets, affirms this sentiment and provides some more background.
It's likely to be a vasodilator, and it has steroidal-like benefits as well. So, yeah, the cordyceps for athletes has been tried and true.
Put simply, vasodilation is the widening of blood vessels as a result of the relaxation of the blood vessels' muscular walls, and is a mechanism by which to enhance blood flow to areas of the body that are lacking oxygen and/or nutrients. Usually, this is good, but in some cases can be harmful, leading to severe hypotension or low blood pressure. I wonder if the fungi notice, or even care. The infected display incredible pain tolerance, strength, endurance, among other qualities that may be influenced by the fungi. Again, I wonder if the fungal infection is closer to some form of symbiosis where human and mushroom tissue merge to form a new type of compound. If so, we might as well throw the anatomy textbook out the window. And considering their lengthy life cycle of the infected, this seems more feasible than the fungus consuming host tissues to survive. And thus, we have entered the wildly speculative phase of the video where late night Dr. Chris turns to Reddit for inspiration. Love this idea on the Last of Us plot hole subreddit from a user named Glitterlamp. Fungi are hardy as and can survive off all kinds of substrates. I mean, you're not wrong. Glitterlamp goes on. They also can produce some very interesting waste products. In many ecosystems, fungi are able to produce chemicals or nutrients that other, typically microorganisms, can survive off of. Maybe cordyceps in the game takes it several steps further. Maybe the fungi are producing waste products that their host can feed on. Maybe the hosts are consuming the fungi itself in some way. Maybe there's an unexplained symbiosis going on that is surviving off of. It's super interesting to think about. And in the name of wild scientific pontification, I'm going to take it even one step further. If the fungus and human tissue merge to create an organism that A, has the movement capacity of a human, and B, has the survivability and mycelial properties of a fungus, then we have a basis with which to explain the extended life cycle of the infected. And also the conundrum that these infected live so long without seemingly performing human survival functions: eating, drinking, excreting regular human waste. Perhaps due to this unexplained symbiosis, they are eating when they are attached to some form of substrate, as the stalkers often do. Hungry? Just lay on the ground near some rotting wood, as suggested by Reddit user House of Hornets X. I've played The Last of Us an embarrassing amount of times, and my headcanon is that because they're basically walking mushrooms, they can also feed off of decomposing wood. Makes sense, because in the areas you can find clickers and older, you find a lot of decomposing infrastructure. I'm sure Big Fella has no problem finding a snack. Look, if I hadn't come across a study that shows similarities between human extracellular matrix and fungal mycelial cells, we wouldn't be here. But welcome to the Wood Wide Web. Yes, you heard me correctly, the Wood Wide Web.
Indeed, there is this thing called the Wood Wide Web. Fungus can communicate chemically over
insane distances. They are remarkable organisms, and unfortunately, in this case, also terrifying.
Say what?
Sometimes it's like the largest organisms you could have in the forest. It's a single organism that could just communicate.
He's likely referring to the giant Armillaria ostoyae fungal colony in Malheur National Forest in the Blue Mountains, Oregon, USA, spanning an area of 8.9 square kilometers, 2,200 acres, and estimated to be 2,400 years old. In an interview with Scientific American, Tom Volk, a biology professor at the University of Wisconsin, explained, "It's one set of genetically identical cells of indefinite shape and size that are in communication with one another, that have a sort of common purpose, or at least can coordinate themselves to do something. Fingers crossed that something isn't devour humans." This organism completely defies our anthropocentric way of thinking. I just hope it doesn't have any tricks up its sleeve, because this...
If you touch a tendril here, a mile away, you could wake up a horde of infected that will now come after you.
Is not going to help me sleep at night. And I hope all those infected were jacked into the wood wide web, because I have no explanation if they've somehow developed telepathy. Now, before my brain turns into a mushroom and I start making sounds like this, I'm gonna call it a video. Thank you all for watching. I hope this gives you plenty to think about on Sunday nights as you enjoy the Rest of Us series. If you enjoyed the fantastic work that my team puts into these videos, then be sure to comment down below and leave them a tip by becoming a member. If you enjoyed the video, be sure to subscribe and leave a comment. If you didn't, be sure to let me know why in the comment section down below. Otherwise, as always, that's been a word from Dr. Chris, not your everyday ortho, where we see one, do one, teach one. He's likely referring to the giant Armillaria osteo. He's likely referring to the giant Armillaria. He's likely referring to the giant Armillaria. He's likely referring to the giant Armillaria ostoyae fungal colony in Malheur.